In this question, we've been given a histogram and we're told that it shows the distribution of the marks of 250 students. We're asked to estimate how many students scored between 52 and 74 marks. First thing here is that we know this data represents a frequency of 250 students. But is that the same as the area we would get under this histogram? The area is not always equal to the frequency. Sometimes there's a scale factor that links them. We'll get started by trying to find the area represented in this histogram. So for the first bar, it will be 0.3 times 20 to get an answer of 6. In the second bar, 1.3 times 20 to get an answer of 26. And I'm just going to label these above the bars in the diagram. So we have 6, 26, 20, 16, and 32. So these are all of the areas for each of the bars. And when we add them together, we get 100. So there is indeed a scale factor between the area and the frequency. We're going to need to try and find what that scale factor is. I'm going to start by saying that the area multiplied by k equals the frequency. The area was 100, the frequency was 250. With some rearranging, we see that k equals 2.5. So any area when multiplied by 2.5 will give us the frequency that corresponds. Okay, now we have that. Can we go ahead and find out how many students scored between 52 and 74? So on the diagram, I'm just going to shade 52 to 74. So it's this red shaded area. What's the numerical value of that red shaded area? Well, we've got 8 multiplied by 1.6 plus 14 multiplied by 0.8. When we add these together, we get 24. And that's the area. We know we multiply that by 2.5 to get the frequency. So we have a frequency of 60. 60 students scored between 52 and 74. In part B, we're asked to use the histogram to estimate the median. Well, we can do this graphically, but a histogram can always be turned into a frequency table quite easily. We know the limits, we know the class boundaries for each of these intervals. 0 to 20, 20 to 40, 40 to 50. So we can find midpoints, we can list frequencies, and we can find cumulative frequencies. And then we can use a lot of the statistical processes that we usually use. We should be able to find the mean, the median, the standard deviation, the quartiles, interquartile range. So many things we can now do quite easily because we've turned it into a familiar grouped frequency table. Okay, so the frequencies here are not the blue numbers that I have written. We need to change each of those into a frequency. We're going to apply the 2.5 scale factor. We're going to multiply each of them by 2.5 to find the frequency. 6 times 2.5 is 15. 26 times 2.5, 65. 20 times 2.5, 50, etc. So that's how we get the frequencies that we're going to use. And to find the median, we also need the cumulative frequency, the running total. It's actually a good sense check here. I was expecting the last cumulative frequency to be 250 since that was the total frequency. This histogram represented 250 students. This is a little milestone to let me know that I'm doing the right thing up to now. Okay, so let's locate the median. There are 250 students. The median will be the middle student, so the 125th, and we just need to find which interval contains the 125th. It's here, the first interval whose cumulative frequency went above 125. We'll just set out our class boundaries, we'll set out our cumulative frequencies. The median is the 125th value. With this all in front of us, we can go ahead and make our fraction equation. Q2 minus 40 over 50 minus 40 equals 125 minus 80, over 130 minus 80. We can simplify and rearrange, and we get 49. The median here is 49. Part C of the question wants us to calculate estimates for the mean and the standard deviation of the marks obtained by these students. This can be done on our calculator. Midpoints and frequencies in list 1 and list 2. Here's the formula for the mean. X bar is the sum of fx divided by the sum of f. All of these we can see on our calculator screen. The sum of fx divided by 250, 51.8. And the same for the standard deviation. The sum of fx squared, the sum of fx, and the sum of f are all right there on our calculator screen. So we can substitute these into the formula to ensure that we get our method mark. And here we get an answer of 22.2. All visible on the original summary screen.